Hello, everyone, and welcome to the future of space. I'm your host, Daniel Fox. Our guest today is Dr. Christopher Mason. Christopher is a professor of genomics, physiology, and biophysics at Weill Cornell Medicine. He's also co founder and global director at Biosia, co founder and scientific director at Onegevity, director of genomics at Tempus Labs, and recently published an amazing book, The Next 500 Years Engineering Life to Reach New Worlds. Christopher, it is a pleasure to have you on the future space.
Well, thanks, Daniel. It's a pleasure to be here. Thanks for having me.
Now, before we go into your topic of favorite topic of conversation, which biotech and the evolution, can you share with us three words that capture the essence of space?
Space, in three words, I think could be summarized as inspiring, necessary, and fun. I think I would say that we have to go, and there's a lot of things that can inspire us to drive and push ourselves to new heights, and then it's also a really exciting place to go.
Now, there's a lot of talks about the science aspect, the technology benefits, the stories that revolve around rockets and billionaires. But can you tell
Yeah.
us, from your point of view, what is the human story of going to space, the life story of going to space?
The human story really revolves around, I think, everything from very subtle and quiet moments of reflection looking at the spacecraft. I'm not an astronaut, but I've just hung out with a lot of them and spoken to many of them about the overview effect, the research they do on orbit, their dreams of going back into space. I think every astronaut I've ever talked to, if you ask them, would you like to go back? They all say yes. So it's a bit of an addiction, but in a good way. And so I think there is this sense of inspiration, like I was referring to before, is that they are really excited by what they're doing, but there is also a real sense of a frontier, that there's a lot that's unknown, that they're exploring, changes in states of matter, changes in cellular and organismal physiology, changes at our body scale that we scarcely understand. And so there is a bit of a frontier mindset, that going into a very dangerous place, and one of the more risky vocations you can have is just to be an astronaut. Your risk of dying is higher than anything else, any other vocation. And so it is not for the faint-hearted, but it does push the limits, I think, of humanity. And so there's everything from the poetry and art that Dr. Proctor made when she was up in the Inspiration 4 mission. So there's this real wonderful part of creativity and art of humanity that's up there. There's some of the fear that has to be conquered. There has to be, also, just real training. I think is the biggest word I'd say, is the training. You have to do things so many times that your risk of failure becomes extremely low.
Now, I believe that the last kind of two other times in the evolution of life on Earth, where there was a quantum leap, there was really a big change in evolution, like the one that we're about to see. Obviously, there was when single
Yeah.
cells became multi cells. There was when the fish came out of the ocean, and then when we came down from the trees. And now we're about to take it from single planet to multiplanetary. And the vision of the future, I think we don't, it's impossible for us to comprehend what is going to be that evolution, because it's going to be so major. I think our realm of understanding is going to be blown away. What do you think?
Yeah, yeah. I think because everything, I talk about this a lot in my book, is that there's been these really extraordinary twin engines of discovery in the past few decades that are fundamentally different from anything that's come before, not just in scale, but also in type. So, the ability to find exoplanets, for example, the first one was found, evidence of it in the late 80s, but really confirmed in the 90s. And for a little while, you could count the number of exoplanets on one hand, in the early 2000s. There were not that many. And so now we have thousands and thousands of exoplanets, many in the habitable zone. So the idea of sending people to other planets was actually farcical for a long time, including a lot of the pioneering work by Carl Sagan and others in the field who were dreaming of these planets. There were no planets to even go to, right? So whereas now we have many hundreds of candidates that we could go to, and maybe even have liquid water, maybe even survive with current technology. But the other real engine of discovery is just about genetics and biotechnology, and the ability to understand the facets of biology that create and craft cells and responses, the number of genes discovered, the number of modifications of genes, which I also talk about in the book, is also has gone from handfuls of therapies and tools and technologies to now things that are being done by high school students who are CRISPRing cells, making their own custom cells. So this playground of biology has become ubiquitous, and the tools have proliferated. So it's really very different time now than it was even 10 years ago, but especially 20 or 30 years ago. It's really fundamentally transformed the view ahead in a good way, I think. So it could go bad. There are ways where things could go bad, but I think it's in a good way, as evidenced by my optimism in the book.
Well, I think that's one of the successes of the human species is to take the kind of randomness or chaos of nature. Because I'm not too sure that nature, I mean, what we've done over the thousands of years is be at the mercy of the change imposed by nature, which is usually you follow the
Yeah.
food source or you follow the climate. And then at one
Okay.
point, we start to create our own, take control of those changes and not follow them. And we've been building ever since on that. Every time that we're limited with what nature gives us, we rise above it. And even now, like every time that you're given a place of birth, now that's nature that gives you, you're born there, but you go beyond it by moving
Yeah.
to different places, by figuring out how to get
Yeah.
different food source. Now obviously we're talking about the level of the planet, so the leap is a little bit bigger, but it's still the same function, the same principle that we're applying. It's just that
Mhm.
it's going to be bigger. Now,
Yeah.
from the point of view of, not that I want to give a personality to life, but from the perspective of life, it never wanted to be limited to the planet because then it would be kind of a almost
It'd be stuck.
a
It would
stupid
die. It would be
investment,
suicide.
right?
Yeah. Yeah. Yeah.
It would be a
Well, yeah, I mean, absolutely. So that's one of the things and I think humans are the only ones that are aware of this frailty of life itself, and so we're the only ones that can actually counteract it. So that's one of the it's part of the moral argument I make a lot in the book is that this awareness gives us a very unique place in the universe. Quite literally, the guardians of the galaxy, or guardians of life, at least in this galaxy, and potentially others. But there is no other entity in the universe with this kind of self-awareness as far as we know. Maybe they're out there somewhere, but we can serve as the caretakers and real shepherds of life itself, because it seems to be pretty rare in the universe. Again, so far, maybe it's out there, maybe it's more than we think of it, but there's the Drake equation, the Seeger equation. There's many people hypothesizing about how much life there could be or might be, but so far it's just us. So in terms of the any species with an awareness of extinction, so until we meet another organism that can do it, or create an AI that can do it better than us, it's just us in terms of having this understanding, and therefore this responsibility, because we're the only ones that can enact this change. And so I think if you were to anthropomorphize life, I think it would like to explore. It would like to go around. It probably wouldn't want to die. If you stay on one planet that eventually will be engulfed by the sun, that's basically suicide, because if we can leave but we don't, then we've stayed for our own demise. And so I think we don't. I don't want that. I don't think other people want that. And so it's really just taking our own personal drive to survive and really expanding that just to the species. It's something we do naturally, but adding a moral dimension to it as well is what I've tried to
mean,
do.
life doesn't want obviously all this investment into pushing the boundaries to evolve. Is to figure out ways to sustain and to move forward. So obviously, the this is one of the things that I tell people is that we are the ambassadors. We are the best and the worst of nature. We're able to emphasize its
Yeah.
destruction, but at the same time elevate this power of creation and innovation to new level. And I think we need to celebrate the narrative as
Yeah,
opposed to say we're a cancer on the planet, because life is
I
messy
agree.
by design. Would you agree?
I agree. Yeah, there are many people. There's misanthropes who think all of humanity should go away. There's people who think all that humans are not worth saving, if you will. I think we are. You could very readily and quantifiably say we're the best and the worst of what life has to offer. But it's as simply quantified by how many species have we made go extinct. Like, I actually, except for invasive species, I don't know if there's an actually documented case of one species obliterating and committing genocide on basically a different species until we came around, right? So I mean, it could have been, and it certainly was always by accident. Whereas, we've hunted things to extinction, right? So there's definitely a bad example there. But we also have resurrected species, like the woolly mammoth is going to be coming back probably in 3 years, or preserve those species that are endangered. So we can do, certainly the best of both. We can kill and resurrect species. We can save and obliterate species. But hopefully, the awareness of this, though, again, I think wasn't until the past few decades. I think much of this was done by accident or foolhardiness or just pure greed or survival. People just didn't have enough food to eat. Infant mortality was too high. People needed a way to just survive for centuries, for millennia. And only again recently have we been able to have, I think, some stability for humanity that we can start to take a breath and not worry that we're all going to be dead by 15 and know that we can plan ahead and plan even intergenerationally. That's all still relatively new. And it's been preceded by like Jeremy Bentham and others who've thought about this for philosophy for a while, but it really wasn't possible, I think, until the world settled down. The other thing I'll point out is that we couldn't really manage or solve global problems until we had a global communication system and ways to coordinate with cultures and peoples all over the world, which also didn't really exist until this last century, and now it's much more easy this century. But that's also relatively new.
I'm pretty sure that you read the book, the Homo Deus, the follow up to Homo sapien, but that was his premise, and where
Yes.
we've been able to control these big killers, famine, war, and diseases, and now the human cost of evolution is not really present. And even I was talking to other in the space, even the human cost of exploration will never, I mean, cross finger and knock on wood, will never be as extreme as they used to be, because now we have the capacity to study and to send robots in advance. Like if you compare the human migration, the European migration, on the boats to North America, how many people died in the process because the conditions, first of all, of the voyage on the
Yeah.
boat was
Yeah.
super hard. You get onto a new continent, you have to
Awful.
start, but now it's not going to
Yeah.
be that
From scratch.
same.
Right, right. That's a great analogy. Is that those seafarers and those adventurers faced far worse odds with much worse technology and very limited understanding of even how, like the fact that scurvy was the thing. People didn't even know how much vitamin C they needed.
Yeah.
Like, they just that was debated until Shackleton's expeditions to the Antarctica even just 100 years ago. It's not that long ago. Some basic things like that we didn't even know. Like just what do you need to eat to survive as a human was still not fully fleshed out, right? So I think it's going to be extraordinarily easier than it was then, and I think the spirit of humanity though is the same. This drive to go to a new place, to discover a new area, and sometimes there's people that are there, but as far as we know on Mars, there's no people. But to really push the boundaries of humanity has been a consistent feature, I think, inspiring one for humans.
Now, I want to pick your brain. I wrote this little piece about how we will live longer, maybe not bigger, because simply
Hmm.
put, the scale of the universe demands it. The living 100 years, living on the planet works because of the distances. But when you get into space where it takes 30 years, maybe 40 years to get from, I mean, even with different, even if you travel at the speed of light, or we'll find different ways, your distances are in a total different scale. Being an ant,
Yep.
when you live in a little sandbox, works, but if you get into the Sahara, you wouldn't survive for one day. So we will have to
Yep.
evolve so that these distances don't feel like they are too big. Like it becomes just like
Mhm.
you take an
Yeah.
8 hour drive. It takes 30 years, but you live longer because of the scale demands it. Would you agree?
I think living longer changes almost everything about how you plan. So I think we can make it so these long distances. I mean, some people talk about hibernation or other ways to get. I mean, do you mean sort of getting to places that are 30 or 40 years away on a spacecraft, or even as I talk about in the book, these ideas of multi-generational spacecraft or generation ships where there are 4 or 5 generations that live and die on the same craft on the way to a planet, which I think is where we may be in about 500 years, hence the title of the book. That's the extreme end of it, and that either we have to have those kinds of plans and ships, or we need to have a 5 to 6 fold increase in the lifespan of humans. I think the latter of those two is going to be harder. Getting people to live longer than like a sequoia, probably not possible from anything we know today, but having people reproduce and have cognitive and psychological metrics to keep people satiated and happy on a long mission is something we can do. I mean, we've all hold up during the pandemic. We all learned how to kind of survive staying in one place. We have a lot more entertainment options than we did. Again, say 200 years ago, you could bring a book with you, but you don't, only so many books fit in a spacecraft, but you can fit the totality of all human culture and literature on a hard drive and bring it with you, right? So there's plenty of things to keep people busy and entertained. Plus, you can stream the latest episodes to spacecraft as they travel away from you. So if you want to stay in touch with Earth, so I think some of these long missions become much more palatable than they could have been even 30 years ago.
So, in our evolution up to recently, in terms of evolution, we were again at the mercy of nature. Whatever evolution or modification was
True.
really kind of biology happening the way it's supposed to be until we start to change it. Even, I mean, now, whether it's reproduction, nature gives you a set that's not working, we go above it. Now with CRISPR, we have the
Mhm.
capacity to change the nature of our species. A lot of people are worried, rightly so. Um, but I do believe that the benefit outweighs the. You can't stop and not go there because there's going to be a lot more positive. Now, going to space, I think that there's going to be a combination of both technology and the biology. The biology is going to happen because we live in a different environment, but we're going to be assisting this
Yeah.
evolution through the technology. What do you say?
Absolutely. So the technology will be, myriad and ubiquitous and powerful. So it'll be inside cells. You'll modify and tweak and reprogram cells as needed. It'll be in surrounding cells and tissues. Say, could it be cybernetic enhancements? It could be external. There's many kinds of new spacesuits that SpaceX is designing that enable a much lighter form factor just to go live in the vacuum of space, which is what Jared Isaacson will do on the Polaris Dawn mission, hopefully later this year or early next year. Just make the technology mix so you can get out, you just float around space and have not have a giant spacesuit. And then even larger things like the spacecraft are thinking about ways to redirect light to help planets be warmer or colder. That's farther in the future, but I think it's also just as interesting to think about that technology from the planetary scale to the cellular and subcellular, helping to keep us alive and drive things forward.
Because I,
But I'm a technophile, so of course I see it. But yes,
well, I think that there's. I mean, if you really look at what we've been doing, that's what we've been doing, and we're just going to be doing it also in space. We've been
yeah,
redirecting rivers. We've been growing crops in places where usually there's none. I do believe,
nothing,
though,
right? Yeah,
that there's the evolution of life, or even our society on the planet, has always followed a couple of um, uh, essential realities. So water, like even if you look at the way we spread on the planet, we always follow water, and we will also follow water as we expand into space. We know that there's a lot of ice, maybe not running water, but there's a lot of ice.
but
And, go
yeah.
ahead.
Yeah, it's out there. It's out there on moons. It's on the planets. Like the ice water is out there. Yeah, or water ice, I should say. Yes. Yep.
And it doesn't make sense to terraform Mars because, I mean, for the reality of energy and time, like there's no point of terraforming Mars. In my perspective, what I do believe is that there other planet like the Earth, and what, like the same way that there's one New York and there's one LA, but along the line in between you have all these settlements that basically are outposts that get you from point A to point B. So there's all these, the moon, the Mars, and all, like we're gonna follow these lines of ice and water that connects these planets of that are resource rich. Do you? I mean, is
Mhm.
that something that you would agree with?
Hopefully, that's exactly what happens because it just like again, the analogy is people moving on the Oregon Trail or moving across the United States in the very early days into territories they knew nothing about but had to find resources along the way. Unfortunately, committed some genocide sometimes along the way. So again, not the good. There's some bad parts about what happened, but in terms of the resource discovery and just survival, we'll see. I think a lot of the same things, and it'll be, there'll be asteroid mining, there'll be moon mining, there'll be ways to make sure people can survive on their way. That'll be, hopefully will work. But we may have to also figure out ways to generate some of our materials on the way, and so it might involve a version of nuclear fusion instead of fission, or other ways to control some of our energy to make the trip. But yeah, I think that'll be, and hopefully there'll be some bars, maybe some like cocktail lounges along the way too. That generally there were saloons, there was beer and things like that along the way. So I think there'll be some places to party a little bit too. I would guess.
Yes, absolutely. There's all going to be. It's. I don't. the principles of evolution on Earth are not different than the principle, or the principle of evolution as we go to space are not going to be different than the ones that were on Earth. They're just of a different scale, but it's going to be the same thing. We're not going to be reinventing the wheel. It's just that our toolbox is going to be different, right?
It'll be you'll get more tools from different planets' boxes, basically. So you will, selection pressure and its variations will still exist, but there'll be different selection pressures suddenly on a new planet. There's acidification levels or densities of atoms that don't exist on this planet that suddenly exist somewhere else, and so evolution will still be at play as it is everywhere whenever there's life, but the forms it takes and the adaptations it needs to create to survive, I'm sure will be starkly different and actually lead to, at one point I called it in the book, is a cross-planetary directed evolution. Is that you could have organisms adapting, for example, on Mars, suddenly have evolved over 30 or 40 years, these bacteria that suddenly have dramatically different phenotypes. You could sequence the organism's DNA, send it back to Earth to then synthesize it and grow up more of that organism to then study it, because on Earth there's a lot more resources. It's hard to do on Mars, but you could have this real, virtuous cycle of learning about organisms' adaptations at many different planets, and then sending the information back and forth as well as the synthesis capacity, so that you can study it across multiple planets at the same time. And evolution has always taught us many lessons. I think we'll just suddenly have a bigger library of lessons from which to read, which are stored on different planets.
Now, technology has changed a lot since the when you begin your career, and where it is now.
Yes.
Are there, like, can you
And I have
share with
less hair. That's also that's just changed. Things have changed. Things have definitely changed. Yes.
can you share with us one discovery that you never thought would be possible when you started your career, and now it is? I mean, CRISPR might be one of them, but I'm pretty sure that you have other ones.
Yeah, good. So I think there were talons and zinc finger nucleases or tal effector nucleases. There were tools that existed before CRISPR that conceptually could do the same thing, not with the same ease or I think specificity or throughput, but that concept was around. There's ways to do gene therapy before CRISPR could do somatic gene therapy with adeno-associated viruses, and that trials in the 1980s and 1990s. People have been thinking about some of these things certainly for decades, so that's not totally shocking. But what I guess was shocking is the ability to do epigenome editing is something that I think people wouldn't have predicted 20 or 30 years ago, where you don't, for a lot of genome editing, you swap out genes or you change them to get a new function. But you can also change how DNA is packaged or controlled, or whether something is just turned on or turned off. So it's in theory less disruptive. You're not changing the genome, you're just changing what's turned on or turned off in the genome. And this has led to some really extraordinary clinical trials for beta thalassemia, for sickle cell disease, where you're basically, for example, we all have fetal hemoglobin. I talk about this in the book. When we're a fetus, you have a different kind of hemoglobin that carries oxygen through your blood than when you're an adult, which is called adult hemoglobin. But if you have a blood disorder where your adult hemoglobin is giving you the disease and causing clotting problems and other issues, one idea was, well, let's just turn back on the fetal hemoglobin that was turned off once you were born, and basically it's just turning off what's called a repressor that keeps it turned off. And so now it's turned on and the patients are doing great. So you actually just turn something back on that is turned off earlier in life. And so this idea of the plasticity of the control of genomes and using it clinically has been a really exciting development. Something we have multiple people in lab working on as we speak, actually, right down the hall. So this is really an exciting time where you can control, I think, the language of life, the letters that are in the page, but then also how it gets read, and sort of real the syntax as well as the forcefulness of the language, and how the life manifests. So that is something I couldn't have really expected. And then I don't know, the sequencing coming down so fast, the ability to just do genetic research really came down 7 to 8 orders of magnitude in a matter of 8 years. So it was really, it was, and as far as I know, still is the fastest pace of technological change that ever has occurred in human history. So really extraordinary, especially as a geneticist, is basically like a time of almost pure euphoria, because you want to look at DNA, sequence DNA, and manipulate it, and it's been never been easier to do all of those things than ever before. So it's been really great.
What are your thoughts about as we enter this era of like genetic customization, where diseases become just more of a challenge than the reality? Do you take the time to think of how can we nurture compassion and humility in the world that it's so easy to become super arrogant and full of ourselves?
Good question. I think there we even parts of the or could you CRISPR out anger or cruelty out of people and make people less pricks, potentially, or make people better or less violent has been, people have talked about this. And I think some of the oldest methods are still the best. I think people learning from old religious texts, even if they're not religious, some of the lessons are the same, that involve humility, compassion, empathy, just really trying to treat others as well as you think you can, and also how you'd like to be treated. And there's just the symbol, the golden rule. It's in every religious text that's ever existed, except for a handful. It was actually in the Anton LaVey, the Satanic Bible, had it inverted. It was, you treat others the way you want to be treated. If you take what you want, kind of thing. So it was the inverted in one religious text, but otherwise, in all the other ones, the same. And I think just getting people to also appreciate the beauty of what's inherent in life. Even engineered life is just as beautiful, sometimes more than what was there before. And so I think, again, people think this seems odd, but these strawberries that we all eat from the supermarket are gigantic compared to their natural previous normal versions. But they're beautiful. They're wonderfully polyploid, crazy chromosome strawberries that are as big as your head. But there was no genetically engineering. There was just selective breeding over many many generations that gave you really interesting features. So I think even dogs like French bulldogs that look really weird, but they're kind of beautiful in their own way. I'd say so. I think remembering the beauty and being humble and being a bit empathic and kind, I think, is good to remind people.
I think that there's a habit in science to these zero sum um, equation situations, and where things can be taken out of context and say they can live over there, when in reality nothing lives disconnected from its environment. There's always relationship, and context is so much important of that relationship. um, and there's always
Absolutely.
unintended consequences in the best of your decision. I mean, I often talk about when people say, "Oh, we have this opportunity of going to space and and decide how we want to move forward," and you know we want to do it with the best intentions. But I always try to remind people that always with the best intentions, there's always unintended consequences, and we have to prepare ourselves with the flexibility and an understanding how life works. Life doesn't want the status quo. Life doesn't want perfection, because if there's perfection, there's nowhere to go. It's constantly mixing, creating disruptions and having
Of course.
tension, because that's the only thing that can move things forward. So, in your world, how aware are people of that dynamic reality of life?
I think in terms of scientists and geneticists and biologists and clinical personnel, if I'm right here by a hospital, I think they're very aware of that. It is a constant gardening that must be done to improve how we treat disease. I mean, if there was no human disease left and no one was dying, you could argue then we've solved a lot of the problems. But we're far cry from that. So I think there is a constant humility about how much we don't yet understand, and this recognition that life, even if you, or even one simple fact is that even if we understood every single piece of DNA and RNA and every cell and everything on the entire planet Earth, and somehow we could have omniscience right now, it would be moot in about 20 minutes because things will start to divide and change, and suddenly life continues to adapt. So there is, anyone who studies biology knows that even the perfect omniscience is fleeting because life continues to change, continues to adapt, humans included. So I think that is weirdly comforting because it, on the one hand, is this ceaseless frothing of new biology, new ideas, new adaptations. So certainly new challenges, but also new opportunities. But it also, you could say, is job security because there will always be things to study because things keep evolving, mutating, and adapting. So at least we'll have things to do, I guess I'd say. So it's not so bad as scientists, I'd say.
But so, do you think, as you personally, do you think that there's a point in the future where we reach a point where there are no diseases, or this kind of almost utopian place that science can take us, or do you believe that every time every time that we solve or the technology takes us to a new place, we just find ourselves with a new set of realities with its advantages and disadvantages. And so we're always kind of um, moving forward and dealing with different problems, but the problems are always going to be there, but with a different shape.
I think it's the latter. The latter, though. So there will always be new challenges, new difficulties, especially as we start to go to new planets where there's, like, as I was saying before, different chemistries, different distributions, literally of the atoms, different components, different threats, and but also different opportunities. So I think that's but that's true for life in general. I'd say so that would be it would be pretty boring, I guess, if that didn't happen. So I think that's okay. It'd be again, there wouldn't be much to do if there's no disease. Most of the hospital here could just we could close the hospital, and or most of clinical medicine and research could be just for fun. And research then would become art rather than for science, and say like you would be doing everything has been solved and known. So you would just then it would just be pure creation. So you just say, well, I'll just make something new because we know everything that exists. But I don't think we'll ever get there. We're always going to find weird things living in strange places, including in ourselves. So I think there's lots to discover still.
I I do believe that we will get to live longer, much longer. I mean,
Yeah.
in the evolution, but is immortality possible? From my perspective, I don't believe so because nature doesn't like it's not to the benefit of evolution. Immortality, you want to be able to have evolution, and if you have something that is just immortal, then it doesn't service life. Do you? I mean, what would you say?
Yeah, I agree that longevity will get better and has gotten better for all of humanity, actually, except for a few dips like World War II and the recent pandemic. But generally, it goes up. The But I think immortality, like we're not going to be like a sequoia tree or a jellyfish that can forever replicate. I think we're too complicated. Some people want immortality in the form of uploading their brain, like the the singularity that Kurzweil talks about is a version of immortality, and I think some version of that might be plausible, but I don't think it would be the same as what we all think about as living. Not yet, at least from what we've designed in systems, computational systems. But I think we would have to the way to achieve immortality would we have to involve wholesale replacement and restructuring reengineering of most cells in the body, which we're doing more and more of and getting better at it. But I think it'll be, I think it's more complicated than we think because it's not just about replacing old human cells with new human cells. As we've seen from the COVID pandemic and other structures, viruses get inside of our cells and become part of the genome. They become part of us quite literally. Nucleocapsids are those like proteins part of the COVID virus, SARS-CoV-2, get embedded in the intestinal lining and then they don't leave. So as we age, we just become this interesting molecular graveyard of things that have come and not left our bodies. We'd have to get rid of them too, and we don't know of good ways to do that quite yet. So I think, but at least now we know that there's weird things that we accumulate, kind of like a big piece of tape roaming the universe, and we can at least see them now. But so there's some work to be done there, but we'd have to know all of that in order to reset the body and live forever.
I love, I love the metaphor of a giant piece of tape just traveling and really capturing. Because I mean, we don't see it, but that's true.
Yes.
Like everywhere, everything, and we need to be
Yeah.
exposed because that's how we develop the immune system, and that's how our body is
Yep.
able to evolve with
Yep.
the
Yeah.
environment.
Yeah. But it can go too far. It can go. But so you need that microbial exposure, especially when you're young, is essential. And actually, one of my favorite clinical trials is if you take kids that are starting to get allergic to peanuts, and if you take all peanuts away from their life, they're actually worse off. They end up being more likely to be allergic to peanuts. Whereas if you have slow, minute doses, which is now actually an FDA-approved therapy, they are less likely to have allergies and response and inflammation. So you do need this training, but then of course it can go too far. You can have autoimmune diseases where instead of having an immune response, it attacks your human cells, or you have an overblown allergic response. So you need the training, but you need to, it's like, do you want to get your training at a karate or jujitsu studio that's very controlled and understood, or do you want to do street fighting and go with lead pipes and brass knuckles and say let's do training? You want it to be a more controlled training whenever you can. Yeah.
Well, the Japanese have this expression "te no uchi," which is the perfect sword grip, and it's one that is strong enough so that you can stop a powerful blow, but one that is soft enough so that you can move rapidly. And that is really the the balance of life and where you create enough tension so that you can stand up. I mean, it's a, a tree is a perfect example of how you need tension to build up, but you don't want too much
Yeah.
tension so that when the wind, then it breaks. And that's like if you think of some of the material, carbon fiber is a really strong, but has it cannot be stressed because then it's going to crack. So as we move forward, it's always balancing too much and not enough tension so that we can move with the flow rather than being, and when you were talking about martial art, that was often the difference between the Western, idea of force, which was brute and just like
Yeah.
all in the power,
Yeah.
as
Strength.
opposed to the Western idea of martial arts, where it was like moving with the energy rather than just like trying to break through the walls.
Yeah. Yeah. It's very different. So I think it's this, and that speaks to philosophy. I think that's just on one planet, these different philosophies. I think as people start to go and live on other planets, there'll be different dialects, different cultures, different philosophies. So I think, but that's part of the diversity of blossoming of humanity in different facets, which I think is fascinating. So I think we'll see more of that in the years to come, hopefully.
Christopher, can you take us like on your book? Someone who's going to buy your book, 500 years. Is it? I mean, did you write this more as a science fiction, or what can someone expect reading the book? What's the evolution through the reading, and what they can find in it?
I, I wrote it so that anyone could read it. So that you start, even if you have no background in science or astronomy or medicine, you can pick it right up and then learn everything you need to know about the most impressive and even sometimes complicated, really feats of modern medicine. But you know how they work at a molecular and even cellular scale of what's happening. So, and the reason I start from zero and take people through all the technologies today is because you need to understand those to understand the light of what's coming in the few years ahead, is that we can use these same technologies to let us actually live on other planets or even go to places we might never have been able to 10 or 20 years ago. So we have these extraordinary new abilities to craft new kinds of cells, new kinds of genetics, frankly, new kinds of species, and even to save species. And so the readers kind of walk through this extraordinary menagerie, this museum of progress that has been built over the past few decades. But then it's not science fiction; it's all nonfiction. It's everything that is a reasonable projection based on what we know today as to what we can expect, and that also includes discussions of the exoplanets, discussions of the technology that can cure cancer in some cases. But it does have some fun parts. There's some odd things in there, like you start to think, well, could we have, for example, vitamin C? We talked about scurvy before. Why can't we make our own vitamin C? And the answer is actually we could if we wanted to. There's actually the gene inside of us for what's called the autosynthesis of vitamin C, and it already exists in dogs and cats. For example, they don't get scurvy; they make their own vitamin C, and the gene that they have is also still inside of us. It's just broken a little bit. So what if we turn it back on and fix it? We working on that in lab now, or increase radiation resistance. What if we add genes from other species and put it into humans? I talk about that. So it's kind of some exciting, new, almost fictional genetic constructs I talk about in the book. The most, I think, comical one is the idea of being a big plant human. So if you had photosynthetic skin, you could lay out in the sun, and he's like, "Oh, I'm hungry. I'm going to go lay outside and just absorb light and have chloroplasts in your skin, be like a green human, a chlorohuman." And I did the math on how much skin you'd need if you just want to lay out for 1 hour on one side. It's about 2 tennis courts worth of skin, which is a lot of skin. But then you'd be all full, and you could go back inside and go in the shade. So there's some fun parts in the book as well. It takes from this, some places technical, but other parts very fanciful and exploratory. Very, I think, fun about what could come. And then at the end, it goes towards, I think, there's a philosophy part. There's a bit of a sense of duty and excitement and optimism about our future that is really embedded in every chapter. That I think people have enjoyed. I think more people would love it.
Do you? I mean, a lot of people think of the human species as this static entity that is at the end of evolutions. Like this was the end goal. Here we are today. But in reality, the human body is still evolving, will evolve even more now
Yeah.
as we go to space. Do you find yourself sometimes kind of imagining what that species of the future will look like? If there are things like in your work you've discovered, well, we don't use our body doesn't really need these things anymore. Most likely they're gonna disappear. I mean, I've had my appendices, taken out when I was young. Obviously, on the evolutionary scale, that maybe will come to disappear. Totally. Like when you look into the future, what do you see for our evolution?
I see a lot of excitement, and frankly, we are going to continue to evolve as we have, of course, in the past. Several million years since our last divergence from a common ancestor. We had lactose tolerance, for example. Eating milk as an adult was really unusual for mammals, but now we can do it, but not everyone as well. And so that's one, or even adaptation to high elevations for Sherpas or deep sea divers in Polynesia and French Polynesia. These interesting selection pressures that have come up just in the past few tens or hundreds of thousands of years, we've already seen. So I think in the future we'll see a lot of selection, maybe the first actual selection for longevity, because since we're changing what the selection pressure is, it really has become more about living longer, not just surviving at all. And so I think we begin to see potentially real selection for, which is unusual for evolution. You just want to survive, not necessarily survive for a long time, because usually you're not reproducing. So we'll start to see directed evolution, as I think eventually also interplanetary directed evolution. And then I also think we'll see flexibility. So I think it would be sad if we designed a human being or modified a human so they could survive on Titan, for example. And like, congratulations, it's very cold, there's a lot of nitrogen, but you can survive. But if you could never come back to Earth or never visit any other planet, that would be actually a limited planetary liberty. Think of, like, liberty is the ability to go do what you want when and where you want to go do it. If you're constrained to one planet, then that's less liberty. So I'd want to think about ways we could have adaptability. Like I mentioned, these epigenetic methods, you turn genes on, turn genes off as you need to enable the survival on different, quite frankly, different planets, right? So I think that is hard to imagine now, but I think is something we're seeing already starting in the clinic. So we know it's not impossible. It's just about getting it technically right and making sure it's actually safe.
Yeah, I agree. I mean, by the way, did you there was a movie done with Titan where they still
Oh
like
yeah, with Sam Worthington, right? I think,
yes.
yeah, the same is basically, yeah. So I published a blog about this in 2015, and then they did that in 2018. So there's a producer at NPR who said, "Are they stealing all the ideas from your lab?" Because it was like something we talked about before. So I said, "No, no, it's an old idea. It's like, I mean, they just made a movie out of it, but it was something I've talked about before." And so there, of course, it's a dystopian movie where things go horrifically wrong. But yes, similar ideas, yeah, definitely.
Are you I don't know if you're a big film fan, but when you watch movies, are you able to leave your science persona behind and look with a certain naivete at the movie, or you're like, oh no, that could not happen. No, no, that would not happen.
No, I can usually, if I know I'm at a movie, there's a particular ritual. I've got paid a ticket. I've got some popcorn. I got some candy. I know where I'm sitting, right? So it's okay to take a moment, but at the same time, it's okay to have check marks of things that you think that's incorrect. I would change that. You can do both at the same time. You can have your critiques and enjoy the fancy at the same time.
There's always a couple scenes in superheroes where this Superman goes and save a plane, and he captures it like right in the middle, and the entire plane stays solid, and you go, no, the reality is that because all the weight is on one place, it would actually break and it falls, or like
Right, right.
flying down or rescuing someone, sweeping them off as they fall. And you're like, no, the arm would actually totally disconnect and detach. There would be a
Right, 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 right. It would not be possible. It's right, right, right.
yeah. So if people want to find the book, um, it's on Amazon and everywhere, right?
Yep, Barnes Noble. You can find it wherever books are sold, but most people order online. There's also the ebook you can buy, and it's now also, it just came out in paperback actually just today. So today is the release of the paperback edition, also with an updated cover and some updated figures, and it's also being translated into Mandarin and also Russian. So it'll soon be available in other languages later this year.
Congratulations. And what's next for you? Is there another book, or are all your companies are working on something that takes all your time? What
Yeah,
is coming up for the next 2 3 years?
some things related. Lots of things. Actually, a lot of this, really, the commercial spaceflight sector has really exploded. So there are now, basically, Inspiration 4 was one of the big missions recently that was done just with SpaceX. So we're working very closely with the medical operations team at SpaceX and doing a lot of the aerospace medicine and astronaut biology, astronaut physiology work that we've done before for other NASA astronauts. Now doing this for Joe and Jane, regular Joe and Janes who just want to go to space. For example, Haley Arsenault is the first prosthetic limb and cancer survivor astronaut who went up into space just 6 months ago. So that was, you're starting to see more normal people, if you will, people that aren't the most perfect specimens of humanity physically, mentally, and emotionally. And they're somewhere between 5'5" and 5'9", because you can't be too tall or too short to fit in the gear. So we're starting to see more people of different sizes, shapes, backgrounds, expertise, ages, and abilities go into space. So it's really a lot more work we've already got planned for the next several years with Polaris missions, other work with SpaceX and Axiom, and of course NASA and the European Space Agency. So a lot of work ongoing to study astronauts to prepare for Martian missions. We're also getting ready for Martian rocks to come back in probably 2033 and to look at the genetics of those rocks to see if there's any sign of life. Maybe we'll look at it. I was working with a lot of others, of course. And I think also just for the companies, a lot of the companies are improving the diagnostic methods that we have. So if you do get sick in space, you could quickly sequence it and understand exactly what has infected you. For the health side, getting probiotics and really thinking of every species that's in you and on you as kind of either a friend or foe that you could bring with you, and hopefully bring more friends than foes. So making sure your microbiome is engineered just like your human cells might be to make sure they're tip top and ready for flight, which is some of the work we do at Onegevity. So I think all these, multiple companies that have spun out of the lab that are helping us to get to do better work on Earth, but then also to survive in space. So I'll stay busy and play, just hang out with my daughter, go to water polo meets, learn some French, hang out with my wife as well. We all speak French sometimes and hang out. So lots of time taking trips on the weekends and exploring parts of New York City.
Is your wife is French or?
Québécois. So she's got the, when she speaks French, it sounds like it's from 1820, which everyone makes fun of her for, but it's very cute. Yes.
So I'm from Quebec originally, so I know exactly what you're talking about. And
Yes, yes.
when
Je parle français. I'm still learning it. Yeah, yeah. But they everywhere she goes, they're like, wait, are you? What is that? They pick up certain words. Like champlure is F.O.S, which is like means like crying, but it's a slightly different word. Or instead of we, it's we.
when
Things like, anyway. There's a small telltales that
yes,
we, yeah. So things like that. Yeah.
gosh, the when I left Quebec 25, 30 years ago, that is one of the things I wanted to make sure that like people would not identify my provenance just by the accent. So my English,
Uh,
even my French,
yeah.
my French sounds more from France than Quebecois, but
Right.
that's funny.
You worked hard, yes. You get rid of it. Good, 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 good. Great, great.
Christopher, it was a pleasure. That was fun, and I can't wait so that we meet in person and we continue this both the biology, the philosophy of evolution. I love anthropology and just the bigger picture of who we are as a species within the context of this world of life and nature. And I think that the era that we're entering is just going to be bringing so many surprises, challenges, but at the same time, discoveries that are just going to open up a vision of the future that is hard to imagine right now.
I agree, and I think we're entering kind of a new age of these algorithms, these tools, these methods. Actually, I do have a new book coming out called The Age of Prediction that's coming out next year. So maybe I'll come back once that book comes out, and we can talk about that, which is how algorithms have embedded everything from medicine to finance to spaceflight. So happy to.
Excellent. Looking forward, Christopher. In the meantime, enjoy learning French and say hi to the family.
Will do. Thanks so much. Great to see you, Daniel.